And that is how you go big or go home. Welcome to another episode of Go Big or Go Home. I'm Dr. J, a professor of organic chemistry committed to the periodic table of eating challenges. And today we find ourselves at Lumpkin's Marina in Virginia, a famous pancake eating challenge. 3 giant pancakes, very low success rate. I'm gonna go ahead and try it, but anybody can at least try that challenge. How many people can finish it in the allotted 30 minutes and then immediately solve an organic chemistry problem as well? That's what we're going to try today. Let's head on in. Hey, how are you doing? Are you Sandy?
I am Sandy.
Sandy, hey, nice to meet you.
Nice to meet you.
So this is Sandy and
I'm Dylan.
Dylan.
Nice to meet you as well.
How long have you been around doing this pancake challenge?
This is my 19th year.
Okay, so 19 years doing the
19
pancake challenge.
And that are the people who has done it in the 19 years.
Okay. Is that the wall of fame? Okay. How many people we got up there? Barely 25 people?
Something like that.
In almost 20 years. So what happens to the typical person who tries it?
Most of them get like maybe one pancake down.
One pancake?
One pancake.
All right, how big are we talking about in terms of these
We're
pancakes?
thinking this big.
Okay.
And
Wow.
it's 3 of them.
3 of them.
They kind of thick.
So those 25 people or so all finished the pancakes,
They did.
but
finish
none
the
of them finished and then did an organic chemistry problem
No,
at
none
the
did
end.
that. No.
So I'm going to be the first one to do that.
Yes, you
All
are.
right, so they told me that they started cooking the pancakes. It'd be about 5 minutes or so, 5 to 10 minutes. Getting a little bit nervous, but we'll take it as we go. It looks like they're about ready. Holy moly. Looks like they're here. Oh, wow.
I wish you good luck.
This is what they look like. So they are the size of a plate that's even a little bit bigger than a dinner plate. So if I finish in 30 minutes,
You get your breakfast free.
Okay.
You get your picture on the wall.
free breakfast and picture on the wall. Like I said, what I'm going to try to do is finish these in the time limit and then stand up before the 30 minutes finishes. I'm going to try to go through an explanation of this organic chemistry problem, and we're going to see how that works out.
Good luck.
All right, so we're here at Lumpkin's Marina at Sandy's. We're about ready to do this 3 pancake challenge. Lots of people have failed. Lots of people have tried over the years. Not many people on the Wall of Fame. But what I'm going to do is attempt to finish these 3 pancakes in the allotted 30-minute time and immediately stand up and then take us through this organic chemistry problem where you're asked to draw all resonance structures of this organic species, right? And so I'm going to take you through that once I'm finished with this. So I've got to give myself enough time, hopefully, to finish it all and then get up and go. I think my strategy is to start with the first pancake with a good amount of butter. As long as the butter's working, we'll stick with the butter. I guess we can go. Let's do it. Good stuff. What do we think?
You got this?
I got this?
You got this. Easily. I'm thinking 12 minutes.
Well, I might pace myself a little bit. I'm not sure. They're pretty thick pancakes. They're really good. What I'm nervous about is if I have all the butter on my hands, is the dry erase marker going to slip out? How am I doing?
Good.
Good.
Actually, good.
I think I'm going to stick with the butter for the second one. Slather it in butter. Ooh, boy. All right, about one down. Almost.
2 minutes, 15 seconds in.
So I think we're past where most people stop already. Well, it sure is a beautiful day. We got the marina behind us, lakefront. Nice breeze, probably about 80 degrees.
The second one down?
Second one's down.
We're 5 minutes in.
All right. I might have plenty of time to actually explain this problem. I'm just thinking I might have maybe like 5 minutes. We're gonna switch to the sweet stuff right now. All right, for the last one, hopefully that's gonna carry me through. Some maple syrup. Making progress. Is it most people stop after one? Have you seen it before or no?
I've never watched it in person. I mean, I've seen people when they're out here doing it, but I didn't watch the whole thing.
Really? Did you see anybody?
They need to watch you.
Did you see anybody win? No.
I haven't.
Closing in on the home stretch.
You got it. 7 minutes.
7 minutes in? Alright. I gotta keep the safety glasses on, you know, in case things are flying. Alright, I got the lab coat. Then you have the safety gear. Starting to feel a little bit like glue. I have a very small and quiet crowd here.
I said they need to watch you eat the pancake challenge.
But I can see why people, you know, stop after one. I'm starting to feel it. These are pretty dense.
It's making me full watching.
How are we doing on time?
9 minutes.
What time you got?
20 minutes and 48 seconds.
20 minutes and 48 seconds left.
20 minutes and 48 seconds left.
Will you get it?
This is amazing. I've never seen anybody. I've been here 6 years. I've never seen anybody.
Never seen anybody doing 6 years, huh?
I don't know. They've had somebody up there. They may have had somebody in 6 years. I just didn't.
Yeah, when's the last time anybody won?
I don't know. We haven't seen.
Yeah. I've been working here since I was a freshman in high school.
Oh yeah?
So this will be my 5th year.
So you work here?
Yeah.
Cool.
I work daunting Marina.
Okay.
But we're not open this weekend.
Let me swallow this last bite.
Yeah, I'm in college right now, so.
Done.
Time.
Last winter was 2 years ago.
2 years ago? Well, it's all gone.
What was the time?
So it took me 10 minutes and 5 seconds, but the challenge is not over yet because I made a deal at the challenge. I got to solve this organic chemistry problem. That's what I'm going to do now. But I have to get all the butter and the syrup off my fingers. This is a problem where I'm going to draw all the resonance structures for this species. What we got to do is take advantage of these, what we call 5 features of resonance up top. Oh my gosh, that's a burp. Oh, there's some gas in there. All right. The first one is some atom that has a lone pair that is attached to a separate pair of atoms that are connected by a pi bond. The next feature is an atom that's lacking an octet. Typically, it's a positively charged carbon that's attached to a pi bond. Third feature is an atom that has a lone pair that is attached directly to an atom lacking an octet. Another feature is an alternating ring of pi bonds. And then the last one is just a pi bond that's connecting a less electronegative to a more electronegative atom. So this is a polar pi bond. To identify what we have here, notice I've got an atom that has a lone pair that is attached directly to this pair of atoms that has a pi bond connecting those two. So I have this feature. What we need to also be able to do is know how we're going to move those electrons around. And for this feature, I got a little bit of butter on my thing to get the cap off. But for this feature, the way that we move these electrons, we start with a curved arrow that tells us that this lone pair is going to move into becoming another pi bond, and it's going to push this pi bond onto this carbon out here, a lone pair. So take that electron movement and apply it here. So we'll do this, move that lone pair into a pi bond, take that pi bond, move it into a low pair. Then we need to use the resonance structure and draw the molecule with the rearranged electrons. So that lone pair turned into a pi bond here, this pi bond turned into a lone pair. So that little part of the molecule will look like this. The rest of it stays the same. So there's a bond here, a double bond, and then the bond to that over there. I still have 2 lone pairs that are on that oxygen. This lone pair that ended up on carbon gives me a negative charge on that carbon. But then what I can do is I can step back and re-look at this entire molecule and see that I've got another feature where I have an atom with a lone pair that is attached to another pi bond connecting the next 2 atoms. So I can go ahead and do the same thing, take that lone pair, swing it into a pi bond. Pi bond goes into a lone pair. Resonance arrow, connecting the two. I'm gonna draw my molecule with the rearranged electrons. So this became a new pi bond. This pi bond became a lone pair right here. And I still have the rest of the structure yet to go. That carbon with a lone pair now becomes negatively charged. So this feature exists one more time. I've got an atom with a lone pair that is attached to this pi bond, but it's also attached to this pi bond. I can start by going on top and then put the lone pair over here, but redraw the rest of the molecule like this. So this became a double bond. This double bond is left as a single bond with a lone pair out here. And then the bottom part here stays the same, still have those lone pairs. The other thing I could do is say something like this, where I showed one electron movement to get to one resonance structure, or I can redraw this molecule and do something like this. So in this case, I chose one path to put the lone pair up here, but I could have used this feature down here. And when I do, I'll get this. So there's the electron movement. Oops. Here's my resonance arrow, and then finally, the final structure. This single bond became a double bond, this double bond became a single bond, and that became a lone pair on that carbon, and that's it. All right, so there you go. We did the pancake challenge. We did an explanation of this organic chemistry problem, all within the time limit. How much time do I have left?
About half.
I got about 15 minutes
You're
left.
16 minutes in, I think.
All right. So everybody, this is Dr. J, and that is how you go big or go home. So I need to ask then, so what's the record time?
9 minutes.
Oh, I should have known that ahead of time.
You almost beat it.
Almost 9 minutes. It took me at 10:05, right?
Yes.
All right. Second
Okay.
place.
How
All
did
right.
you do it that fast?
He strategized.
I did strategize.
Yeah.
Got some butter, mostly
Yeah,
butter.
butter.
Tell me about this horse. How old do you think it is?
I think it was maybe the 60s.
In the 60s?
Yeah.
It doesn't still work, does it?
It does a dime.
I do, but here we go. Oh. Dr. J riding off into the sunset.